Welcome to your college physics course. This will be your first topic, Introduction and Measurements. As for the learning outcomes, by the end of the lesson, the students will describe what are the scientific methods and its application, enumerate the two categories of physics, explain the importance of numerical measurements, describe what are the four fundamental quantities of measurements, differentiate what are the systems of units, solve problems involving conversions of units, express derived quantities in terms of the four fundamental quantities of length, mass, charge, and time. Describe what is accuracy and precision means, explain fractional error and uncertainties, and differentiate significant figures. Historical background. Physics has its birth in mankind's quest for knowledge and truth. In ancient times, people were hunters following the wild herds for their food supply. Since they have to move with the herds for their survival, they could not be tied down to one site with permanent houses for themselves and their families. Instead, these early people lived in whatever caves they could find during their nomadic trips. Once they stayed long enough in one place to take care of their herds, they found that seeds collected from various edible plants in one year could be planted the following year for a new crop. Thus, many of these ancient people became farmers, growing their food supply, so they could of course found that they could grow a better crop in a warm climate near a readily available source of water. For the first time in the history of humanity, obtaining food for survival was not an all-time consuming job. These ancient people became affluent enough to afford the time to think and question. What is the cause of the regularity and the motion of the heavenly bodies? What makes the sun rise, move across the sky, and then set? What makes the stars and moon move in the night sky? What is the earth made of? What is man? And through this questioning of the world about them, philosophy was born. It is the search for knowledge or wisdom. From the Greek word philos means love of and sophos means wisdom. So philosophy therefore originated when these early people began to seek a rational explanation of the world about them. It is an explanation of the nature of the world without the recourse of magic, myths, or revelation. Ancient philosophers studied ethics, morality, and the essence of being as determined by the mind, but they also studied the natural world itself. This later activity was called natural philosophy. It is the study of the phenomena of nature. Natural philosophy therefore studied all of nature. The Greek word for natural is physikos, and therefore the name physics came to mean the study of all nature. Then, physics became a separate entity from philosophy because it employed a different method to search for truth. Physics developed and employed an approach called the scientific method in its quest for knowledge. There are 5 scientific methods, and these methods must be done step by step, starting to the first step, which is observation. You need to have your observation first before you can make your hypothesis. And then from your hypothesis, you need to make your experiment to prove your hypothesis. And from your experiment, you can have your theory or law, and then lastly, the prediction. First is observation. The first step in the scientific method is to make an observation of nature. Meaning to say, you need to collect data about the world. The data may be drawn from a simple observation, or they may be the results of numerous experiments. Hypothesis. From an analysis of these observations and experimental data, a model of nature is hypothesized. The dictionary defines hypothesis as an assumption that is made in order to draw out and test its logical or empirical consequences. That is, an assumption is made that in a given situation, nature will always work in a certain way. If this hypothesis is correct, we should be able to confirm it by testing. And this testing of the hypothesis is called the experiment. So from this flow chart, from your observation of nature, you can go to hypothesis. And from your hypothesis, next is your experiment. Experiment is a controlled procedure carried out to discover, test, or demonstrate something. An experiment is performed to confirm that the hypothesis is valid. If the results of the experiment do not support the hypothesis, the experimental technique must be checked, okay, to make sure that the experiment was really measuring the aspect of nature that it was supposed to measure. If nothing is wrong or nothing wrong is found with the experimental technique and the results still contradict the hypothesis, that's the time that your original hypothesis must be modified or you change your hypothesis into something. Another experiment is then made to test the modified hypothesis. The hypothesis can be modified and experiments redesigned as often as necessary until the hypothesis is validated. So there's this arrow in here looping the experiment and hypothesis with one another until you have your hypothesis validated by your experiment. You can go to theory. Finally, success. The experimental results confirm the hypothesis is correct. The hypothesis now becomes a new theory about some scientific aspect or some specific aspect of nature, a scientifically acceptable general principle based on observation or observed facts. After a careful analysis of the new theory, a prediction about some presently unknown aspect of nature can be made. So, from the theory, you can have your prediction and you can modify your theory by doing another prediction about presently unknown aspect of nature. If your theory or your hypothesis is correct and there's no evidence that your theory is wrong, then that's the time you can make your theory a law. Is the prediction correct? To answer that question, the prediction must be tested by performing a new experiment. If the new experiment does not agree with the prediction, then the theory is not as general as originally thought. Okay? Perhaps it is only a special case of some other more general model of nature. The theory must now be modified to confirm the negative results of the experiment. Then the modified theory is then analyzed to obtain a new prediction, which is then tested by a new experiment. So again, this is a loop experiment. You need to make your prediction correct so that you have your scientific method or scientific findings become a law, or else it will only be a theory. This process of prediction and experiment continues many times. As more and more predictions are confirmed by experiment, mounting evidence indicates that a good model of way nature works has been developed. And at this point, the theory can be called a law of physics. What are some of the examples of laws of physics? Example is the Newton's law. Okay, Newton's have made a scientific observation, and from his observation, he has formulated the laws of physics, or he has contributed some laws that is very useful in our physics. This method of scientific reasoning demonstrates that the establishment of any theory is based on experiment. The realm of physics. So physics can be defined as the study of the entire natural or physical world. And to simplify this task, the study of physics is usually divided into the following categories. So our course or our subject is fall down into the classical physics, wherein we will study about mechanics, wave motion, heat, electricity and magnetism, then the light. Whereas in the modern physics, we are studying about relativity, quantum mechanics, atomic and nuclear physics, condensed matter physics, elementary particle and high energy physics. Physics is a science of measurement. In order to study the entire physical world, we must first observe it. And to be precise in the observation of nature, all the physical quantities that are observed should be measured and described by numbers. So take note of the physical quantities that are being observed. It should be measured and described by numbers. That's the point where the fundamental quantities were developed. Therefore, to measure the entire physical world, we use the four fundamental quantities of length, mass, time, and charge. What are these? The fundamental quantity of length is used to measure the location and the dimensions of any object in space. The speed of light has been measured 299,792,458 meters per second. And using this value of the speed of light, the standard meter can now be defined. The meter is the length of the path traveled by light in a vacuum during a time interval of 1 over approximately 300 million of a second. Therefore, the fundamental quantity of length is now determined in terms of the speed of light. Take note that the speed of light is always this number, and that is in meters per second na unit. So, the speed of light and the fundamental quantity of time. Fundamental quantity of time is second. So, the meter thus defined is a fixed standard of length, and it is accessible to everyone and non-perishable. So, an illustration in this equation, distance is equals to speed of light times time, whereas the speed of light is 299,792,458 meters per second. So, the time is in second. So, you can have your second cancelled, and this value 299 cancelled. You will be left with meter, or that has 1 in here. So, that is equal to 1 meter. There are 4 different measures of length. It is the foot, the yard, and the inch, and also the meter. So, technically, there are 4. This foot, yard, and inch are units in a British English units. What is the British English units? I will tackle that later on. So, meter is the standard unit of length. And there's also foot, yard, and inch. So what is foot? Historically, the foot was used as a standard of length, and it was literally the length of the king's foot. Every time you change the king, you change the measurement of the foot. Okay, that's the reason why nagawa itong si foot. Next is yard. The yard was the distance from the outstretched hand of the king to the back of his neck. Obviously, this started of length also change with each king. So, obviously, you will have an imagination of where foot and yard was originated. Next is the inch. The inch was the distance from the tip of the king's thumb to the thumb knuckle. With this very arbitrary and constantly changing standards of length, it was obviously very difficult to make a measurement of length that could all agree on. It is why this unit of foot, yard, and inch were termed British, British English units, no? Kasi sa British merong king. And si king is dahil nga king siya, his servants are using this king as their standard. So since king is okay, sabi nga dito, obviously very difficult to make measurement because it is constantly changing, meaning the size of the king is constantly changing. Not all the time napayat siya, or not all the time is mataba siya, or there are certain times na matangkad siya, or nung bata pa siya, then biglang tumangkad. So, lumaki yung mga measurements or mga lapad ng kanyang paa, the hand, and also the knuckles and the thumb. So this is why the standard of length is always in meter. And from this unit of conversion, you can have your meter turns into inch, and into foot, and into yard. You could memorize this. The system of measurements based on the meter was originally called the metric systems of measurements. Today it is called the International System of Units, or SI. The letters are written SI rather than IS because the official international name follows French usage, or Le Système International d'Unités. This system of measurements is used by scientists throughout the world and commercially by almost all the countries of the world except the United States and one island in the Indian Ocean. So again, these are some of the unit conversions of 1 foot into meter, 1 yard into meter, inch into meter, and 1 mile into kilometers. Don't be confused with the word kilo and centi. Okay? When we say kilo, that is in thousand. And when we say centi, that is in hundreds. Okay? Let's talk about this later on. Next is the standard of mass. The simplest definition of mass is that mass is a measure of quantity of matter in a body. In 1795, the French Academy of Science initially defined the standard as the amount of matter in 100 cubic meter of water at 0 degrees and called this amount of mass 1 kilogram. This definition was changed in 1799, 4 years later, to make the kilogram the amount of matter in 1,000 cubic centimeter of water at 4 degrees Celsius. It is the temperature of the maximum density of water. However, in the 1889, the new and current definition of the kilogram became the amount of matter in a specific platinum iridium cylinder 39 mm high and 39 mm in diameter. And the metal alloy of platinum and iridium was chosen because it was considered to be the most resistant to wear and tarnish. Okay? Copies of the cylinder, like in this figure, are kept in the standards laboratories of most countries of the world. So, you can remember that the standard of mass is always in kilogram. The standard of time. The second is defined as the duration of 9,192,631,770 periods or cycles of the radiation corresponding to the transition between two hyperfine levels of ground state of cesium-133 atom, like in this figure. The atomic clock is located at the National Bureau of Standards in Boulder, Colorado. The atomic clock is accurate to 1 second in 1,000 years and can measure a time interval of 1 millionth of second. So, okay, I will not elaborate this instrument because, again, the most important thing is the standard of time is always defined as second. Next is the standard of electrical charge. The fundamental unit of electricity is defined as the ampere. Ito yung sa kuryente natin. Where the ampere is that constant current that, if maintained into straight parallel conductors of infinite length, of negligible circular cross-section and placed 1 meter apart in a vacuum, would produce between these conductors a force equal to 2 times 10 to the minus 7 newtons per meter of length. Thus, ampere, the unit of current, is also defined as the passage of 1 coulomb of charge per second in a circuit. This represents a passage of 6.25 times 10 to the power of 18 electrons per second, and therefore, the charge of 1 electron is 1.60 times 10 to the minus 19 coulomb. So, the standard of electrical charge is coulomb. Don't be confused because ang coulomb is nagmula dahil dun sa experiment ni Ampere or yung kuryente, electricity natin na kuryente, Ampere, or Ampere is the unit of current. Okay? And again, there's this experiment na straight parallel conductors of infinite length. Infinite length, big sabihin super haba na hindi na mabilang or hindi na ma-measure. Negligible circular cross-section and placed 1 meter apart in a vacuum would produce between these conductors a force equal to 2 times 10 to the minus 7 newtons. So they come up with that 1 coulomb of charge per second in a circuit represents 6.25 times 10 to the 18 electrons per second. Okay, just always remember that the standard of electrical charge is coulomb or electrons per second. Systems of units. When the standards of the fundamental quantities are all assembled, they are called systems of units. The standards for the fundamental quantities discussed in the previous sections are part of a system of units called the International Systems of Units, abbreviated as I. So in table 1.1, there's the systems of units. Physical quantity, let's say length, mass, time, electric current, electric charge, weight, or force. In the SI or International System units, okay, the length has a unit meter, and then mass is kilogram, time is second, electric current is ampere, electric charge is coulomb, and weight or force is Newton. Well, in the British English system, like I have talked about, or we have talked about the king, the length is all about his foot, mass is all about slug. When we say slug, we'll discuss this later on. If we encounter slug, I'll discuss this later on. But most of the time, we are only talking about kilogram as for the mass. Time, second, and weight or force, pound. Okay. Conversion factors. A conversion factor is a factor by which a quantity expressed in one set of units must be multiplied in order to express that quantity in different units. The number of a conversion factor are usually expressed as an equation relating the quantity in one system of units to the same quantity in different units. Example, converting feet to meters. The height of a building is 100 feet. Find the height in meters. So by conversion of factors, 100 feet here in our solution is equals to 30.48. How was that? To express the height h in meters, multiply the height in feet by conversion factor that converts feet to meters. So the conversion factor of 1 meter is equals to 3.281 feet. These conversion factors or units of measurements are found in your appendix or in the end of your module. So, for you to cancel out feet, you need to place feet. Okay? You know that 1 meter is always 3.281 feet. So, you need to place the feet in the denominator so that you can cancel that feet. And you will be left with meter. So, copy the meter unit. Now, 100 times 1 divided by 3.281 is equals to 30.48. That's the simplest way to convert feet to meter. Notice that the units act like algebraic quantities. Okay? When we say algebraic quantities, this ano ba tawag dito? Fraction, because there's numerator and there's denominator. This fraction always act as an equal. Also, kumaga 1 meter per 3.281 feet. 1 meter equals 3.281 feet. Ganun siya. Next is example day. 1 day converted to seconds. So, when we have a day in the numerator, you need to place the day in the denominator. So, again, this conversion of factor is seen in your appendix, or obviously, you know that 1 day has 24 hours in it. Okay, this is a basic knowledge you need to know. 1 day is always equals to 24 hour, so it can cancel the day. Now you'll be left with hours. So next, what is next with hour? Of course, minute. So 1 hour is equals to 60 minutes. So you need to place the hour here so that you can cancel out the hour up. Okay? Next is you need to convert the minute into second because again, you have to convert the day to seconds. So you know that 1 minute is 60 seconds. So you cancel minute, you'll be left with seconds. Place it in here. Now, 1 times 24 times 60 times 60 divided by 1. Okay? 1 lang kasi wala namang multiply dyan kundi 1 lang. So, you are just simply multiplying 24 times 60 times 60 and that is equals to 86,400 seconds. Most of the quantities that are observed in the study of physics are derived in terms of the fundamental quantities. For example, the speed of body is the ratio of the distance that an object moves to the time it takes to move that distance. That is expressed as speed, wherein speed is equals to the distance traveled over the time, or simply V equals the length over the time. As a final example of a derived quantity, the density of a body is defined as its mass per unit volume. That is, density rho, this is a Greek letter rho, equals mass over volume. And you know that a volume is always in the power of 3 or cubic. Okay? Area is in the power of 2 or squared. But volume is always in the power of 3 or cubic. So, density is always equal to the mass over unit volume. All the remaining quantities of physics are derived in this way and in terms of the 4 fundamental quantities of length, mass, charge, and time. Learning activity 1.2, converting cubic feet to cubic meters. So, the volume of a container is 75 cubic feet. Find the volume of the container in cubic meters. So, to make it simpler, this conversion factor is just the previously known 1 meter is equals to 3.281 feet. Syaro din nyo pa ma-memorize ito, ha? 1 meter is always equals to 3.281 feet. So, now, you have to 75.0 feet cube written like this. If this is feet, you only have to think about the conversion of feet, which is 1 meter equals 3.281 feet, and you need to place it below so that you can cancel out feet. But again, stop muna kasi you cannot just cancel right away the feet. Okay? Because there's this 3 above that feet, calling it cubic feet. So you need to multiply both the unit of 1 meter into 3.28 cubic feet. You need to power that up into 3. Okay? If you put 3 in that, so this is power of 3. Okay, so 1 to the power of 3 and 3.281 to the power of 3. When you input that in your calculator, always use 3.28 to the power of 3 or 3.28 times 3.28 times 3.28. Okay? Now, you can now cancel your feet because you can cancel the 3, you can cancel the feet, and also you can cancel the feet, and you can cancel the 3 for this feet. And there's also 3 for this meter. Okay? Parang dinistribute mo si 3. This is part of your mathematics, so I hope I am assuming that you know how to solve problems involving powers. So you can have meter, copy, and 3 copy. Assuming that you have the value 3.28 cube. Okay? So 75 divided by 3.281 cube is equals to 2.12 cubic meter. So this is the answer. Okay. O, see? Na-elaborate pala siya dito. Yun nga lang, don't be confused kasi mayroong value dito. Itong value na to is just the value of 1 over 3.28 281 cube. I-calculate nyo ba? This is equals to 2.83 times 10 to the minus 2. So, you cancel the feet, cube, and then you'll be remained by cubic meter. Next, converting horsepower to watts. A certain engine rated as having a power output of 200 horsepower. Find the power rating of this engine in SI units. So, this conversion of factors is again in your appendix A. So, 200 HP. 200 HP has a conversion factor of 1 HP equals 746 watts. You have to replace the HP below so that you can cancel the HP or the horsepower unit and you'll be left with watt. Okay, so 200 times 746 is equals to 1.49 times 10 to the 5 watt. Uncertainty and significant figures. Measurement always have uncertainties, and if you measure the thickness of the cover of a hardbound version of a book or any book using an ordinary ruler, your measurement is reliable only to the nearest millimeter. Okay? Your result will be 3 millimeter. It would be wrong to state that the result as 3 millimeter given the limitations of the measuring device. You can tell whether the actual thickness is 3 millimeter or 2.85 millimeter or 3.11 millimeter. You are just assuming that the thickness of your book is 3 millimeter because your ruler cannot really read that much. So, here, your ruler only reads 1, 2, 3, 4, 5 increments and another 1, 2, 3, 4, 5 increments. So, in this 1 millimeter, you have 10 increments. I mean, in this 0 to 1, you have 10 increments of millimeters. So, this one is 1 millimeter, 2 millimeters, 3 millimeters, up to 10 millimeters. But if you use a micrometer caliper, what is this? This is a device that measures distances reliably to the nearest 0.01 millimeter. The results will be 2.91 millimeter. Again, don't be confused with the word milli associated with the meter. Kasi the standard of length is always meter, but here it is called millimeter, meaning to say it's meter. The distinction between these two measurements is in their uncertainty. The measurement using the micrometer caliper has a small uncertainty. Okay, small uncertainty compared dun sa ruler na 10 increments. Hindi mo mabasa yung in-between dun sa increments na yon. It is more accurate to measure certain thickness using a micrometer caliper because the uncertainty is also called error, and it indicates the maximum difference that there is likely to be between the measured value and the true value. So, as you can see, the thickness of this circle in here is read as 17.92 millimeter. Okay? If you are reading here, okay, you can read that increments. Again, this is 10. So, again, 17. No? Pero meron siyang point something. If you're using a ruler, you can read that by 17 millimeter. But if you are using a micrometer caliper, this 0.92 millimeter is making a difference. So, okay. We often indicate the accuracy of a measured value, that is, how close it is likely to be the true value, and by writing the number and the symbol plus, minus, and a second number indicating the uncertainty of the measurement. Precision is not the same as accuracy. It is a cheap digital watch that gives the time as 10:35:17 a.m. is very precise, and the time is given to the second, but if the watch runs several minutes slow, then this value isn't very accurate. On the other hand, a grandfather clock might be very accurate, that is, display the correct time, but if the clock has no second hand, it isn't very precise. A high quality measurement is both precise and accurate. For this figure, you can see that in high accuracy and high precision, where's my mouse? So, this is kumbaga, ito yung aim target mo, yung nasa gitna. And this is your, kumbaga, ginawa mong targets. So, you have high accuracy. Okay? High accuracy kasi nasa gitna ka ng yung or nasa target ka, and high precision because all of your X or all of your targets are in the bullseye. Ganun ba? Yun ba yung term doon? Next, sa figure na to is low accuracy and high precision. Bakit kaya low accuracy? Low accuracy kasi ito yung target natin, but ang layo. So, low accuracy. High precision kasi lahat halos ng tinira mo is nandoon sa labas. So, and nasa labas pero magkakadikit. So, next is high accuracy, low precision. High accuracy kasi halos lahat ng target X mo is nasa bullseye. Pero yung precision natin is medyo hindi kumbaga low kasi magkakahiwalay sila. Hindi tulad dito, no? High precision kasi halos magkakadikit. Dito malayo. Next is low accuracy kasi obvious naman na hindi natamaan si bullseye, and low precision kasi malayo sa isa't isa. Now, We often indicate the accuracy of a measured value, that is, how close it is likely to be the true value, by writing the number, and then the symbol plus and minus, and a second number indicating the uncertainty of the measurement. If the diameter of a steel rod is given as 56.47 plus and minus 0.02 mm, ito yung sinabi dito, by writing the number, this is the number, the symbol plus and minus, and the second number indicating the uncertainty of the measurement. So this is the uncertainty of the measurement. This means that the true value is unlikely to be less than 56.45 or greater than 56.49. How was that? 56.47 minus 0.02 is equals to 56.45. So that's your lower, okay, kumbaga lower uncertainty measurement mo, and this is your higher uncertainty measurement mo. We can also express accuracy in terms of maximum, likely, fractional error, or percent error, and also called fractional uncertainty and percent uncertainty. Example is a resistor labeled 47 ohms plus and minus 10%. Probably has a true resistance that differs from 47 ohms by no more than 10% of 74 ohms. That is, 10% of 74 ohms is about 5 ohms. Okay? Kung i-calculate nyo yan, 10% of 47 ohms is always 5 ohms. So, you have to add 47 plus 5 is 52 and 47 minus 5 is 42. So, this is your lower uncertainty measurement and this is your higher uncertainty measurements. It is probably between 42 and 52 ohms. For the diameter of the steel rod given above, okay, the fractional error is 0.02. Okay, ito siya, sa fractional error natin. Or yung uncertainty measurement natin, 0.02. Next is you have to divide it by 56.47, your original number. Okay, when you divide 0.02 divided by 56.47 mm, you can have about 0.0004. Okay? And that 0.004, when you multiply that into 100%, like in this, you can have 0.04%. So, even small percent errors can sometimes be very significant. Okay? In many cases, the uncertainty of a number is not stated explicitly. Instead, the uncertainty is indicated by the number of meaningful digits or significant figures in the measured value. What are these? A significant figure may result to different ways because in multiplication and division, it is based on the fewest significant figures doon sa starting number. So, this is the starting number. Okay? The fewest significant figure in here is 2. Or this one. And you can count it 1 and 2. So, 2 significant figures. That is why when you multiply 0.745 times 2.2 divided by 3.885 in your calculator, you can have as many digits as here, 0.422222. But since we have two significant figure using this multiplication and division in here, you only need to put two significant figures, or you only need the two significant figures, which is 0.42. Okay, another example. In this 1.32578 times 10 to the 7 times 4.11 times 10 to the minus 3. So, compare this. Okay? Kumbaga yung equation na yan is like ganyan. Kasi times 10 to the minus 3 times 10 to the positive 7 are a significant number to the power of 7. Okay? So, you need to base on the digits. So, the viewer here is 3, 4.11, which is 1, 2, and 3 significant figures. When you input this, when you input this value in your calculator, you can have 5.45 eclabush times 10 to the 4. So, you only need 3 significant figures for your final answer and then add the power. Next, the significant figure is different in the addition or subtraction. Why is it? Just always remember that in addition or subtraction, only the decimal place is counted. Okay? So, dito, the decimal place is 3, decimal place is 1, then decimal place is 2. So, the viewer is only 1. 1. So, if you are to calculate 27.153 plus 138.2 minus 11.74 equals 153.6. Meron pa yan sunod-sunod, but you only need to put one significant figure in this decimal area. Okay? When we calculate with a very large or very small numbers, we can show significant figures much more easily by using scientific notation. And this is the scientific notation I'm saying. Sometimes we call it power of 10 notation. Power of 10, power of ganyan. The distance from the Earth to the Moon is about 384 million meter. Okay, so when you write 384 million meter into powers of 10th notation, you only have to put or to write the 384. Okay? And why is it meron siyang tuldok dyan? Okay? It's because there's this kumaga hidden na. Kasi diba 0.0 pa yan. So, from this point, you move to the left. You are moving to the left. And when you are moving to the left of the numbers, you are counting it positively. This is why positive C8. Okay? So, ilang count or ilang jump? 1, 2, 3, 4, 5, 6, 7, and 8. That is why 3, then point, 84 times 10 to the 8. Okay? Now, in this form, it is clear that we have 3 significant figures. Okay? The number 4 times 10 to the minus 7 also has 3 significant figures, even though 2 of them are zeros. So, sa significant figure, kahit pa 0 yan, basta significant siya, you have to write it. Kahit pa 0 pa yan. Now, what is, for further explanation of this powers of 10th notation, it has minus 7 in it. Anong itsura niyan? If we are to write that 7 zeros, 1, 2, 3, 4, 5, 6, 7. Okay. This time, you are counting to the right. Okay? So, this is your starting dot. There's 0 in here. Okay? Dito rin naman, may 0 dyan. But it is not necessary because this is a bigger number. Dito, kailangan siyang isulat, okay, to indicate that this is a small number. So, you are going to the right because you are going smaller. So, 1, 2, or 1, 2, 3, 4, 5, 6, 7. Okay, so nandyan si 4. No, mali ako. Okay? I need to correct myself. So, when we say minus 7, 1, 2, 3, 4, 5, 6, pang 7 yung nalagyan ng tuldok. Okay? So, dito, pag itataklaw natin yan, ganito yan. 1, 2, 3, 4, 5, 6, 7. So, this is the correct answer. Okay? So, 4.00 times 10 to the minus 7 is like this. 0.000004 or pang 7th si 4. Significant figures in multiplication. The rest energy E of an object with rest mass m is given by Einstein's famous equation E is equals to mc squared, where c is the speed of light in vacuum. Find E for an electron for which the three significant figures, ayan, indicated na in the problem, the mass is 9.11 times 10 to the minus 3 kilogram, and the SI unit for E is joule, or 1 joule is equals to 1 kilogram meter squared over second squared. So from this equation E is equals to mc squared, we have the value of m, and we also have the value of c, speed of light. Speed of light is 3 million times 10 to the minus 3, or to the minus 8. Okay? Or 299, to be precise, 299,79248,2458 times 10 to the 8 meters per second. So, from the appendix, ito siya. So, 9.11 times 10 to the minus 31 kilogram times, okay, si M kasi yun eh. So, si C is 2.99792458 times 10 to the 8 meters per second, close parenthesis, and copy the squared. Copy the squared. Now, you can power this one. Okay? You need to power that into 2. Okay? In your calculator, you just have to input this value and then to the power of 2 and then i-times mo siya dito. Okay? No need to complicate things. Then, so from your calculator, you can have this value. Bakit ang haba ng number? Okay? Kasi hindi pa siya final. So, kailangan natin siyang insignificant figure later on. Copy the kilogram, copy the meter, and the seconds. But, do not forget your squared or the power. So, pag nag-power ka dito, you also need to power the meter or the unit, meter, so meter squared, and the power of second is 2. Kaya siya ganyan. So, since the value of m was given to only 3 significant figure, kasi nga multiplication siya, ginawa mo, so you only need to read the fewest value. So, alam natin na si speed of light has very numerous number. Ito siya. Pero yung given mass is 9.11, so 3 significant figures. So, we only need 3 significant figures from this value or from this calculated value. And 3 significant figures is this one, and this one. Since 8 is magkatabi sa 7 and 7 is a bigger number meaning 5 and up. Okay? When we have 5 in here, you need to convert that into 9 again. But if you have 4 in here, remain 8. 3, remain 8. So, since 7 siya, you need to round up. So, 8.19 times 10 to the minus 4. Copy this one, then kilogram meter squared, then second squared. Or, simplification, because nasa SI unit tayo, and the SI unit for joule is 1 kilogram meter squared second squared, which is this one, or simply joule. So, this is the answer. So, that ends our lesson 1 topic. As for the lesson summary, we have these 12 subtopics. I hope you have understood what I have said or what we have tackled. And if you have questions, we may have sessions regarding in this topic. Thank you for listening, and I hope you have learned a lot.